In the second part of this video, I want to show you how to create a dome surface. For now, we're just focusing on creating a dome and the different ways that you can create a dome. And then we kind of map that folded plate module onto that dome. So the first step for creating a dome is to define an arch, right? So the simplest arch we want to now create is a circle, and we can say I want to create a dome on XZ plane. I want to create a circle on the XZ plane, and the radius I want it to be between 1 to 40. So here it is. I can make it as a floating number and set the number of digits to just 1 decimal place. And here is the circle that now I have. Now, the next step is to split this circle into 2 parts. Splitting a curve in Grasshopper is kind of tricky. You should either split that curve by using another closed curve or a surface or a B-wrap. Now what I'm going to do is defining a rectangle again. Rectangle. It can be similar to our previous rectangle, but with this difference that the plane will be in XZ. So here it will be a rectangle, and also I wanted to actually, instead of sliders, let me just show you something that how you can define a very large size rectangle. You can say I want to define a rectangle from -100 to +100. You can also define the length as this. And for y, I want to say from 0 to -3. So I'm going to have like a giant rectangle, right, like this, that intersect with my circle with any radius that it may have. Okay, I just intentionally defined the length, the XY length of the rectangle as big as possible to make sure that it will definitely intersect with my circle. Now, the next step is to find the intersection point. There is a curve to curve intersection. With this I cannot get it. Maybe I can just key in CCX, which is curve intersection. Where you can find that is going to the curve ribbon under, if I'm not wrong, analysis here. Let's see. It's always like tricky to find these components under these tabs. I usually use the search button to find it. Utilities. There is that. Analysis. Curve. Oh, where are you? Come on. Utility. Oh. It should have like this kind of shape. Oh, sorry. Yeah, under intersection. There we go. Under intersection, you will find that curve intersection. There we go. Okay. Now, I want to find the intersection between the circle and this rectangle. Now, there is a function which is called shatter that let you split a curve at some points, okay? So at some segments. So I'm gonna connect this circle. This is what the curve that I want to shatter. And this t is the parameters to split at, okay? Here I'm gonna have like the points that let me split the curve. Now, if I click on the shatter, you'll see the same circle. But the output says there are two defined values. It means there are now two defined curves. Now I can key in list item and choose which item I want to pick. So the index item 0 give me this upper curve. That is what I really want. Now let me turn off the preview of the other items. So this is the curve that I have. Now I can revolve. Here it is, the revolve this curve and create a surface. So here is the profile for curve. Then it asks for the axis. Axis can be a simple line, and the line can simply get started from 0, 0, 0 to 0, 0, 100. Again, a very large axis. Okay, there we go. Here is the surface that I defined. Here for revolving, the degree is 2 pi. You can also say pi. Here we go. Because by just 180 degree, you can create the surface. Okay, so here's the first way to create a semi-spherical dome. Let me group it, give it a name, creating a sphere by revolving an arch. And we have it here. There is also another way that you may say, well, sounds very simple, and that is just like creating a primitive surface, a primitive sphere, and then split it. This is also possible. So you can just say, let me just turn this off. What is the sphere, or what is the base plane? I would say XY. And what is the radius? I would say 1 to 40. And there we go. Now the next part is to split that B-rep. Split the B-rep. So I'm going to split it. And then what would be the cutting shape? So the cutting shape can be a circle, in XY plane with the same radius, and there we go. And if you take a look, it says that there are like two locally defined values, and I can again list item and turn these off and get this one. Well, apparently this way looks pretty simple. But later when we map the folded plate dome, you will see the difference of how you create that surface. I mean, what would happen then if you create that surface by using a sphere? So I'm just here grouping them and say create here. So these are two ways to create a cell. Now, in the next part of the video, I will explain for you how to map that solar plate module